Hey everyone, and welcome back to BlackboardAI. Not less, not more, exactly. Look at this example array, 135275. minK is 1, maxK is 5. The subarray 135 works. Minimum is 1, maximum is 5, perfect. But 13, nope, maximum is 3, not 5. 5275, nope, minimum is 2, not 1, and 7 is bigger than maxK. How do we count all of them without checking every single possible subarray? That would be too slow. We need something slicker. Enter the sliding window approach. We use 3 special indices. Let us call them JBAD, JMin, and JMax. JBAD is the party pooper index. It remembers the last position outside our minK to maxK range. Think of it as a bouncer saying nope, you cannot start your valid party back there. Initially, JBAD is -1, before the party even starts. JMin is the minimum maestro index. This tracks the most recent position where we saw our minK. We need this guy in our valid subarray. Initially, JMin is -1. JMax is the maximum monarch index, tracks the most recent position of our maxK. We need this one too. Initially, JMax is -1. If yes, this element ruins any subarray including it. Update JBAD to I, the new boundary of badness. Step 2. Spot the VIPs. Is the current number equal to minK? If yes, update JMin to I. We found our minimum star. Remember where they are. Next, is the current number equal to maxK? If yes, update JMax to I. The maximum monarch has arrived. Note the location. Step 3. The magic calculation. How many new valid subarrays end at the current position I? A valid subarray ending at I must contain both the most recent minK and the most recent maxK. It also cannot contain party poopers. This means the subarray must start after JBAD. So a valid starting position J must satisfy JBAD less than J, less than or equal to minimum of JMin and JMax. How many integers J satisfy this condition? It is simply minimum of JMin, JMax minus JBAD. But wait, this could be negative. We cannot have negative subarrays, so we take the maximum of 0 in our calculation. The final amount is maximum of 0, minimum of JMin, JMax minus JBAD. At index 2 number 5 updates JMax to 2. Count adds maximum of 0, 0 minus -1, which is 1. Total is 1. At index 4 number 7 is a party crasher. JBAD becomes 4. Count adds maximum of 0, 0 minus 4, which is 0. Total is 2. At index 5 number 5 updates JMax to 5. Count adds maximum of 0, 0 minus 4, which is 0. Total is 2. And bam, final answer is 2. Just like the example said, we did it. Efficient, slick, kind of funny when you think about the party pooper index, right? So there you have it, LeetCode 2444 demystified. Remember the key, track the last bad index, the last min, and the last max. Calculate the valid starting range using maximum of 0, minimum of JMin, JMax minus JBAD at each step. If this breakdown helped you conquer this hard problem, smash that like button, subscribe to BlackboardAI for more. Leave a comment below. What problem should we tackle next? See you next time on BlackboardAI.